Good morning. Before I get started, I want to say I hope that everyone is doing okay out there. Let's just go ahead and jump right into this. This lesson is for my Honors Integrated 1 class. This is for section 2.5 in our book. So let's just jump right in and talk about our goals. We have 3 goals today. Our first goal is going to be to talk about the difference between the concept of and or. It's how 2 conditions relate to each other. And what it means, what has to happen for that to be true? What has to happen for an and statement to be true? And what has to happen for an or statement to be true? We're also going to talk about the graphs of these and or situations. And we're going to solve these, and these are called compound inequalities. So when we have a compound inequality, we're either dealing with an and situation or an or situation. All right, so let's just go ahead and jump into our first goal. An and situation, both conditions must be true. And I have a story about this that hopefully it makes sense conceptually what I'm talking about. I have a friend, his name is Louis, and Louis is a very talented guy. He's whatever he puts his mind to, he's able to accomplish. Like, for example, I believe he can play any instrument he wants. He doesn't drive, but saw a organ piano on the side of the road and had his friends help pick it up. It was broken. He took it home. He decided to fix it. No background in that, but he fixes it. He read a book about tying knots, and then he had all these beautiful knots all over his house. He's also extremely colorblind, and he's so colorblind, in fact, that he has trouble telling, it's hard for him to see different shades of the same color. And that's important for the story, that it's hard for him to see shades of different color. So this example is about Louis' fish. And Louis decided that he was going to have a saltwater fish tank. And when you have a saltwater fish tank, you have to make sure that the water is not too salty or it's salty enough, right? And so the way that you test to see if your saltwater fish tank has the right salinity is you take these strips and you put it in the water, and then you take it out and it changes to a certain maroonish shade, and then you have to match it up on a guide, and it'll tell you if you have to add any chemicals to your fish tank. Well, I was at Lou's house one day, and he was testing the salinity of his fish tank because he had a new sea anemone that he was introducing into the environment, and so he wanted to make sure that it was going to be healthy. He dipped the tab in the water, and he put it next to the guide, and he asked me where it fell, and I did my best to say, oh, it's right here, and I ended up leaving right after that, and I saw him a couple weeks later, and I asked him how his sea anemone was doing, and he said it died, and I said, oh, I'm sorry, was it my fault? He said, no. But the point is, about the Louis fish, is that the salt water has to have a minimal amount of salinity, but it also has to have a maximum amount. So if you're below, the fish will die. If you're above, up to a certain point, the fish will live. And if you go beyond that, the fish will die. So I guess it'll be kind of important to see what an and condition would look like. And I'm just going to jump into the second goal. So this would be the minimum amount of salinity in the salt tank, and this would be the maximum amount. So you have to be above this amount and below this amount. So both conditions must be true. You have to be above and below in order for the fish to survive, right? So that's an example of an and condition. The second type of compound condition is the or. And I have an example, and I call it my potato salad example. And the thing with potato salad is if it gets to be a certain temperature, or a range between a certain temperature, bacteria grow, and if you eat this potato salad after the bacteria have started to multiply, you could get what my mom calls the collywobbles. You're not in for a good day. But anyways, there are certain temperatures that the bacteria don't grow at. They don't thrive in cold conditions, and they don't thrive in hot conditions. And so in order for the potato salad to be safe, for example, it must either be kept at a temperature that's lower, or it must be kept at a temperature that is higher. So either one of these happening is good enough for the condition to be true. Now, this is a little bit more of a mathematical concept where the temperature, like the refrigerator would keep the bacteria from living, or when you're above a certain temperature where bacteria can't live. But you probably don't want to eat potato salad when it's that hot. But again, these are important concepts in mathematics, in law, and in computer programming. So you're going to see these concepts quite a bit. And so let me check off the first goal. So I wanted to point out the difference between and or, and I'm going to finish talking about the graphs of and or. Now, you're going to be asked to write a compound inequality that represents an and graph and an or graph. And I'm going to say this is not the only or graph there can be, okay? This is the classic one, but they both could be going in the same direction. They both could be overlapping, but this is just technically the classic or type situation. So let's talk about how to write the inequality of our and compound and situation. And that's pretty easy to do. And again, I want to just use simple language. I'm going to say that the shading is between A and B. Okay, so the shading is between A and B, and so I'm going to put these inequality symbols to show where my shading is. So the shading, or A is left of the shading, which is true, and the shading is left of B, which is also true. So this would be how you write an inequality for compound and graph. Okay, pretty easy to do. Let's talk about how to write the compound inequality for an OR graph. Again, let's just talk about left and right and shading. So the shading, which is our variable, is left of or equal to C, or the shading is right of the value of D. So that's how we would talk about the graphs of these things. And conversely, or in the backwards way, if you were given this, you graph both of these on the same graph. And if you were given this compound inequality, they're telling you the lower boundary and the upper boundary. Just make sure that you have the circles either closed or open. So I'm going to go ahead and check that off. All right, so let's move on to our third goal, and it's solving these compound inequalities. So if I gave you this compound inequality as and I know that it's a compound inequality that represents and because I have a lower boundary and an upper boundary, lower boundary and an upper boundary. So I'm going to go through the steps to solve this. Now, if I gave you this inequality, you would solve this by adding 3 to both sides, then dividing by 3. I should have picked a better number, but sorry about that. If I was to solve this compound inequality, I would also add 3 to both sides, then divide by 3. So in solving both of these separate inequalities, hopefully you come to the realization that you can solve them both at once. So this step is a little tricky for some of you guys, but we're going to solve them all at the same time. So I'm going to subtract 3 from in between. I'm going to subtract 3 from the outside. And this, I'm going to subtract 3 from the boundary, the lower boundary, the upper boundary, and the value in between the boundaries. So now that cancels, and I'm left with 3 is less than or equal to 3x, and that's less than or equal to, or just less than, sorry, to 9. So again, this is how you would solve that inequality, and this is how you'd start to solve that inequality. My last step in solving this inequality would be I would divide out the 3. And same with this. I would divide out the 3. So that's how I would solve that. That's how I solve that. But we can just all do it at one time. So that means that the value of 1 is the lower boundary. And the shading is between 1 and 3. And did I lose? Yes, I lost that. 1 and 3. And so you're going to be asked to graph this. And again, there's my lower boundary. There's my upper boundary. So there's my 3, it's an open circle. There's my 1, it's a closed circle. And I just shade between. Okay, so that's how we're going to solve a compound inequality in the and form. In the or form, you're just going to solve 2 independent, separate inequalities. You solve them and then you graph them both on the same graph, and you're done. So let's see here. So this first compound inequality, I just solve very simply by dividing by 2, and we get the shading is right of 4. The second compound inequality, I divide the negative 2. Now remember, when we divide by a negative, we're changing the order of we're changing the position of the numbers, so I have to just change the description of them. So now I'm going to say that negative 2, instead of being on the left, is now on the right of x. But I don't like to graph in this form, so I'm going to switch the order. So if negative 2 is on the right of x, that means that x is on the left of negative 2. So again, we're going to see our classic graph for this compound inequality. The shading is right of 4, and the shading is left of negative 2. Okay, so all of these concepts on the board should be enough to get you through the section 2.5 homework. I will be having a Zoom meeting about this lesson later today, but I hope that it makes sense. And again, you see these concepts of and or quite often in law and in computer programming. So that's our lesson. Have a good day.